Hi again. This is where we left off with our program, where we made use of those basic transformations of translation, scale, and rotation to create something a little bit more visually interesting. In today's video, we're going to take a look at adding one extra layer of abstraction so that we can encapsulate everything that we've done inside a new object type called a particle system, with the hopes of being able to create multiple particle systems without very much additional effort. So let's close this program, and just like we have created this user-defined class particle, let's create a new one called ParticleSystem. And we'll set it up much as we did before with our particle class. We're going to call it ParticleSystem, and it has a constructor. And just like for our previous program, we care about that emission location. So we're going to want to have passed into our particle system, if we make a particle system which will be responsible for managing all the particles, just like we had in our previous program, it's going to need to know where that emission location should be. Now, in terms of some of the class properties, we're just going to need to be able to store the x and the y of the location, and then we're going to need an array list of particles. In fact, I may just take this from our original program, because we're going to wrap a lot of what we had done in our main program and put it inside of this particle system. So we still have that mutable data container, the array list that's going to hold all the different particles, and we can initialize our x and our y in this constructor. Those are the only two variables I think that we're going to need. In terms of other functions, we may just need one function. I'm going to call it run. And again, this is going to be very similar to the type of code that we had in our main program before. Right? When I create a new particle system, whenever we're running it, and we're going to run it once per frame of animation, it's going to make a new particle. It's going to check if the particles are still alive, and if they aren't, remove them from the system. So we can actually reuse a lot of the stuff that we had in here. So I'm going to take out this line and move it over to our particle system. Particles.add, that's right, so we make a new particle at the middle of the screen. This we might do a little bit differently, because when we create a particle system, we're asking for its emission location, stored as an x and a y, as an argument. And so we've set our x and our y to be equal to whatever was passed in. So let's use those at our emission location. They might be the middle of the screen, but it could be anything. And that's the kind of flexibility that we're going to want. Now, just like we had before, we're going to loop for each of the items in our array list. See if we can fix up this formatting a little bit. In fact, there is an auto format function, which is quite handy sometimes. So for any particle that's currently in the system, we're going to move it and we're going to display it. So right now we haven't done a lot of new programming. We've really just moved all the logic out of here and put it inside this particle system class. So if we wanted to basically recreate the exact same functionality, we would just need to create one instance of this particle system. So if we say particle system main, and we'll initialize it in the setup, so main equals new particle system, and let's use our classic middle of the screen, width divided by 2, height divided by 2, and then we can just say main.run. This is actually the identical program to what we had before. We've added sort of a layer of abstraction that helps keep things nice and neat and organized. We'll see actually that the program behaves the exact same. We create one particle system, and every time we use that run function, And the run function is really just what we used to have in the main loop. Now, doing this extra work did make it neater, which I guess in and of itself is nice, but it also lets us create more complex programs. So instead of just having a single particle system, we could create an array list that can hold multiple particle systems. And maybe calling them systems might make more sense. Equals new array list. It's going to hold our particle system. And now we do need to change this main.run. Instead of what we had before, we're going to want to use a loop to iterate through our array list of particle systems. Now at the start, right now, we don't have any, which is fine, right? If the size of systems is equal to 0, then this loop just doesn't run at all, which is the behavior that we would like. We want it to run once for everything in the system, and if there's nothing, it shouldn't run at all. And so to access the particle systems, we'll use systems.get the system at position I, and a particle system has the function run, so we can call the function run on that system. Now if I were to hit run right now, as we would expect, nothing happens because we don't actually fill the array list with any systems. We have no new particle system call. So that's something we're going to want to fix. Now, an easy way that I think will work well for us is just to use built-in function void mouse released, and this function just gets called anytime you've clicked the mouse and you let go of the button. It's going to activate this function. So there's an event handler that sort of tracks that event happening, and whenever that happens, let's add a new particle system. And if you recall, remember, whenever we make a new user-defined object, we need to pass in the appropriate arguments to match with what's in the signature. And if we look at the signature, we're expecting two integers, which are going to represent that emission location, the X and the Y. So, a really convenient two arguments might just be our mouse X and our mouse Y. Wherever we click, let's create a new particle system there. So if we were to run this, now if I click, you can see that we can create a new particle system each time, and really make for some kind of interesting dynamic visuals on the screen. And this is really just scratching the surface, right? We could do all sorts of things with these capabilities. This is a great example of how we started with something simple, and then we were able to make something that's visually reasonably complex. Alright, take a look at working through this code, and hopefully you can replicate this yourself, and then think of some neat ways that you can extend this. I mean, our particles are very basic. We're not doing anything interesting with color or shape. The possibilities are really quite endless. So have fun and make some really interesting programs.